Welcome to MathSol. In this video, we are going to see the distance between two lines. So if I just show that if we have a line, one line here, and there is a, like, let's say it's a straight line, and we are making another straight line here, and you can see they are intersecting. So the distance between two lines are not constant; they are changing, right? Here is a maximum, then it's going down, and then it's coming zero, then again it's increasing. But if I have a parallel line like that, and I ask you what is the distance between two lines, someone can measure the distance from here to here. Someone can measure the distance from here to here. So it would be different distance. But if I make a distance from this point to that point, which is vertical to each other, so vertical line, make a vertical line. So distance between from here to here, this point to this point, is the same. So it means if I make a vertical distance between two parallel lines, they are always constant. So it means when the question asking to get the distance between two lines, we are actually asking for the distance of perpendicular distance of two parallel lines. And this is the example that I started with. There is xy plane. You can see there are two lines, and they are looks parallel. And the first equation I showed before, it is 2x plus 2, and the second one is y equal to 2x minus 2, and you can see y equal to 2x plus 2 and 2x minus 2. So it means our gradient is 2, so both gradient is same, so it means that they are parallel. So now we are looking at the perpendicular distance. So it means any point from this line, we can make a perpendicular line and see where it is touching, and then we can get the distance between 2 points. That's the one way of doing, right? Or what and then, okay, but most of the times the graph is not given, so question probably is asking just y equal to 2x plus 2 is the given equation, another given equation y equal to 2x minus 2, and these lines are parallel, and find out the distance between these two lines. Then what we need to do, we just, as I said, we need to find out any point from one line. So let's say we are just trying to find out any point from the first line, and it is easy to see our first equation. It is easy to see that our point is 0 and 2. Why? Because we know that 2 is the y-intercept and m is the gradient. So it means the y-intercept point is 0, 2. So 0, 2 is this point basically. And now if I ask you perpendicular distance from 0 to this line, so it means if you make that line, it is making 90 degree, right? So it's a 90 degree perpendicular distance, so from this point to this point. So we don't need to find out what is the point. You can also get the point by making the equation of the perpendicular line, and you can see the intersection with the second line, but it is time consuming. What we can do, in order to get the distance from here to here, we can just get the perpendicular distance from 0 to point to second line. Second line means y equal to 2x minus 2. So y equal to 2x minus 2, we can write down this equation in the general form, which is 2x minus y minus 2 equal to 0. So this is the general form of the second equation. So from the first equation, I am getting 1 points, and which is y-intercept, and then from the first point and from the first equation, and from the second equation, I'm just making it as a general form. And if it is in the general form already, then you don't need to do anything. Now we can just apply a formula which is called the perpendicular distance from a point to a line. And there is a if the point is x1 y1, I'm just writing the formula. And if the equation is ax plus by plus c equal to 0, then according to the formula, it is saying that perpendicular distance d will be absolute value of ax1 plus by1 plus c, and then underneath is square root of a square plus b square. So this is the formula, and a and b, you know, is the coefficient of x and y. And in the equation part only, we just instead of x and y, we are just substituting with the x1 y1 point, whatever the point is given. So in that case, if we just do that substitution now, it will be a x1, and in our case is a 2x. This is our equation, right? This is the equation. So we are basically looking the this point and perpendicular distance from this point to second equation, right? So it is 2 times x means 0, because we have 0, 2 is the point, so 2 times 0, I can just put times, yes, then plus b is minus 1, so and then 2 is y value, so we can just put minus 2, right, and then minus 2. So this is absolute because it's a distance. Whatever value is coming, it doesn't matter it's a positive negative, we always considering the positive value, right? And then underneath it will be just a square, so a square means 2 times 2 square, and then plus b square means b is minus 1, so minus 1 square means 1 square, same thing, minus 1 square. So now if I just write down that part, it is just write down here, it is 4 plus 1, 5 square root of 5, and on the top it would be minus 4, so we can just write down is a 4 because it's absolute value. So the distance between these two parallel lines, it will be 4 over square root of 5 unit. So it means if I go for any point from here to here, it would be also the same, because as I said, anywhere perpendicular distance will be the constant, so anywhere from here to here it will also be the same. So all through the perpendicular distance between these two lines will be 4 over square root of 5, but for our convenience we are just trying to pick that y-intercept, because getting y-intercept is really easier from the equation. But if the equation general form, you can either choose x-intercept, y-intercept, doesn't matter. So the first equation we are using to get the point. Second equation we are just converting in the general form to get the general form of this formula, and then we just apply the vertical distance formula from a point to a line. Thanks for watching. Please subscribe my channel to see more up-to-date videos.